Hello! Yes, and welcome to our Objective 5.1 notes, our first set of notes for Unit 5. These set of notes are all about in behavior. Our objective, I can identify the in behavior of a polynomial from the equation, and that's what we're going to do. Unit 5 is all about polynomials, and polynomials are functions in the form of this is our coefficient, a variable, and an exponent. And then we add or subtract another coefficient, and then variable, and then exponent. And we go down the line all the way till we get to a constant. Now, the graphs of polynomial functions have two really distinct traits. The first is that they're continuous. There's never going to be a gap or a space. They're going to continue from negative infinity to positive infinity. They're continuous. The second is that they only have smooth round curves. There's never going to be any sharp turns or anything like that, like in an absolute value function or anything like that. It's going to be a smooth round curve. So the first thing that we're going to talk about when we're introducing the graphs here is standard form. And standard form of polynomials are when the terms are ordered from largest exponent to smallest exponent. All right, now the degree of the polynomial is the value of the highest exponent in a polynomial, and leading coefficient, that's a term we should be familiar with. That's the coefficient for the variable with the highest exponent, with the highest degree. So some examples to get us started here. We're just going to practice writing stuff in standard form, identifying the degree, and the leading coefficient. So if I look at letter A here, x squared plus 3x to the fourth minus 2x plus 5x to the third minus 8. This is not in standard form because our exponents are not in order from least to greatest. So if I wanted to put these in order of the exponents from greatest to least, it'd be 3x to the fourth plus 5x to the third plus x squared minus 2x minus 8. And now this is in standard form. Notice we can easily go 4, 3, 2, 1, and then no variable there, right? No exponent. Okay, so this would be a fourth degree, right? It's from that first exponent, and our leading coefficient would be 3. Okay, and that's important to recognize here. So let's look at B here. This one is almost in standard form. We would have negative 8x to the fifth plus 7x to the third minus 4x squared plus 11. So my degree would be 5, that's my highest exponent, and my leading coefficient would be negative 8. All right, a couple more here. So this one, negative 4x to the third minus 9x squared plus 7x plus 18. So this would be a third degree polynomial. My leading coefficient is negative 4. And my last one, let's see, we have x to the fifth minus 3x to the third minus 9x plus 10. So this would be a degree 5 polynomial. And in this case, my leading coefficient is just 1. I'd imagine a 1 being in front of that x to the fifth there. All right. And once we're feeling confident with that, we can start to elaborate on end behavior of graphs, because that's really what this is all about. So in behavior recognizes the direction of the graph of the polynomial is going as x approaches positive and negative infinity. So what that means is as I go to the left or as I go to the right, is the graph going up or is the graph going down? So if in our degree, if our highest exponent is odd, we have two options, and it depends on the leading coefficient. If the leading coefficient is positive, then we say the graph falls to the left and rises to the right. And here's an example. See how as I go left, it's falling. As I go right, it's rising. Now, we don't care about what happens in the middle. We just care about the end behavior. Now, if the degree is odd, all right, so our highest exponent is an odd number, and the leading coefficient is negative, then that gives us what letter B. The graph rises to the left and falls to the right. Okay, again, we don't care about what happens in the middle. None of that matters to us. We just care about as I go all the way to the left, is the graph going up or down? As I go all the way to the right, is the graph going up or down? So notice if it's odd, they're going in opposite directions. So an odd degree polynomial is going to go in opposite directions. That's not the same case for an even degree polynomial. If the leading coefficient is positive for an even, right, for an even degree, so 2, 4, 6, or 8, then the graph rises to the left and rises to the right. It's going up in both directions. Again, don't care about what happens in the middle. None of that's important to us. We just care about the end behavior right now. And then if the leading coefficient is negative, the graph falls to the left and falls to the right. It's going down in both directions. Okay, so your goal for today is to be able to basically recognize what's happening here, okay? If the polynomial is an odd degree, we're going to have alternate directions. If the leading coefficient is positive, falls to the left, rises to the right. If it's negative, rises to the left, falls to the right. If our degree is even, our highest exponent is even. If the leading coefficient is positive, it's going to rise to the left and right. If the leading coefficient is negative, it's going to fall to the left and right. All right, so let's do some examples here. Make sure we understand, can hit this home here. So, rewrite the following polynomials in standard form, determine the end behavior, and then we can check our answer if we want. Okay, so first thing, we have to put this in standard form. So we'd say f of x equals, and this one's almost just entirely reversed. It is entirely reversed, actually. 4x and then plus 3. So I have an odd polynomial with a negative leading coefficient. So that means, if I check my graph up here, odd polynomial with a negative leading coefficient. So that would give me this situation. So this graph rises to the left and falls to the right. And that's what I would put here. That's my answer. Rises to the left and falls to the right. Okay. Looking at letter B. So I need to distribute this all out. So I'd say f of x equals negative 5 halves x to the 4th minus, what would that be, 5x and then plus 5 halves. Kind of a strange one. Okay, so even degree, x to the 4th, even with a negative leading coefficient. So that means that graph would falls to the left and falls to the right. All right. Now looking at letter C, this one's already in standard form, isn't it? 5, 3, 1, 0. So that checks out. So all I need to do is my end behavior. We have a odd degree with a positive leading coefficient. So this would be falls to the left and rises to the right. And there we have it. Hopefully, end behavior is starting to make some sense. I want you to go ahead and get started on those sample problems, see how we do. Feel free to work with a partner on those if you would like. As always, reach out if you have any questions. We'll go through these together as well. This is Mr. Carter signing off. I'll see you next time.